Let's, okay. Well, in principle, we have three types of facilities for investigating catalytic reactions. First, we have facilities, so-called surface-sensitive technique like Auger, lead, UPS, XPS, etc., for investigating the surface events on the single crystal surfaces. Secondly, we have so-called classical surface-sensitive technique like infrared. We have three infrared spectrometers. One of them is Fourier transform infrared spectrometer. And last but not least, we have facilities for classical heterogeneous catalytic work. We have gaze chromatographs for investigating our catalytic reactions in flow or any mode. You will see all of this naturally. But the main concept for doing that if we investigated surface events of a given catalytic reaction on a given single crystal like palladium, we would investigate these surface events with the help of classical surface-sensitive technique, infrared, and we do catalytic experiments on the same catalyst. Probably you have seen our lecture at the Budapest conference. Probably not, because you were sitting in room Patria and this lecture was delivered in room Bartok. So this lecture would be one of the excellent examples for this combination of the technique, because this lecture was delivered on the methanol adsorption on palladium single crystals, investigated by Auger, UPS, XPS, and also on methanol adsorption on supported palladium, investigated by infrared. So that's only an example for doing our experiments. So if you don't mind, start in showing our facilities, right? May I introduce my colleague, Dr. Károly Révész.
Károly Révész,
he is doing such kind of experiments here. So, there is a traditional UHV chamber providing opportunities for doing experiments with Auger, lead, TDS, TPD measurements. So the single crystal is sitting in the UHV chamber, and you can see here some facilities for doing these measurements. There is a mass spectrometer for TDS, TPD measurements, and all is computer controlled system, and and we can get our results through the computing these rough experimental results coming from the facilities. But I see the type, the shape of this UHV chamber is the same in everywhere of the world. So right now my colleague Imre Kovács is investigating here the adsorption of ethyl chloride on palladium. As you have seen during this symposium, we are busy with this topic. I mean the halogenated hydrocarbons, catalytic destruction or decomposition, and that's why a deeper insight into this process would be of great help in interpreting these data. The first step, what happens on the surface of single crystals like palladium. So that's why he's investigating right now the ethyl chloride adsorption on palladium single crystal surface. So shall we go further? Well, this is another type of our UHV systems equipped with a hemispherical analyzer, and in this UHV chamber Károly Révész is studying the photodissociation of different halogenated hydrocarbons. Naturally, he has started with the most simplest, methyl chloride, methyl iodide, etc., etc. This is a very traditional lamp for having a light which can decompose the surface, adsorbed surface, methyl chloride, for instance. That's all. The facilities for Auger, lead and UPS measurements, photoelectron spectroscopy, you can see. Right. Computer control system too. And in this lab, we have here the Fourier transform infrared machines. This is a well-known traditional infrared chamber here. Formerly it was called Kisarev type. But the interesting part of this chamber is its bottom part. Because having a copper block inside the cell, we can cool our sample sitting here at the bottom, in the bottom part of the cell till, let's say, 133 Kelvin. So to very low adsorption temperature, and we can investigate the adsorption processes from this temperature up to room temperature if we want to investigate what happens at higher temperature. We can move our sample from the bottom to the middle part of the cell with the help of this magnet. Okay, this is a BioRed. As far as I know, this is a US-made Fourier transform. It's well-known in the... And a very traditional vacuum and gas handling system belongs to the infrared cell. So, in this laboratory we have these three facilities, and as far as I have mentioned, if, let's say, Károly has been studied the adsorption of methyl chloride with the help of XPS on palladium, I have investigated here the methyl chloride adsorption on silica-supported palladium. So that's a direct way of the information coming from here, and I am giving to him another information from infrared. Okay, I will show that the... Figyelj, most azt mondja, ugye nem baj, hogyha a Bird Davisnek bemutatja.
Still here, oh, very glad to see you. Oh, fantastic, you know, because we have more time to show you.
Okay, shall we go?
I did a record of...
Would you like to have something?
I just have to grab it.
Okay, please go. So this is our brand new experiments, an STM1. It has started just a few weeks ago. So these STM scanning tunneling microscopy is very helpful to know, to investigate what happens on the surface in atomic scale. So it would be of a great help if we can see the atoms or adsorbed molecules themselves with the help of this one. Laszlo Buri, one of my co-workers, is working on it. He is discussing right now with Professor Solymási. Probably after this discussion he will show to you some very interesting picture obtained so far, because it's a fantastic, ethically fantastic picture to see, right? Naturally, it's computer controlled system, and picture obtaining system is also here. János, it's a picture. Have you met János is during the symposium? May I introduce you? János is, Dr. Davis from US. He has just returned from US.
Oh,
From Austin, Texas.
yes.
Okay, János, can you open the door of
No,
the first?
unfortunately not. I don't have any key.
Safety, safety.
No, so Lassie has.
Oh yeah.
This
Please,
is a new machine.
Contains some OG and lead apparatus here, and those mass spectrometer. And just that. This guy. So,
well, excuse me, János. I have promised to you. Here is László Deák.
Yeah.
Oh yeah.
He's
How do you
working
do?
on this system, and I asked him to show you some excellent picture obtained so far by
do you have
STS.
first?
Yeah.
Yes, I have. All right.
And we can go into the first.
Yeah. We have atomically resolved pictures on graphite, but unfortunately not on other metals, because the corrugation on graphite is much more than on metal surfaces. But we are interested mainly in metals and absorption of gases on metal surfaces. And the effect, of course. Please have a seat here. And what do you deal with? What kind of apparatus you have yourself?
We have more reactor systems.
At higher pressures?
Yes. We have XPS, OJ. They're building STEM, but it's
Yeah.
not operating yet.
Yeah. These pictures were taken on a graphite surface, and you may see here some steps. And we could reach the atomic resolution even without the isolation of noises, of mechanical vibrations. Okay, these were eliminated, but we didn't use these isolation lags. Simply we tested our STM head, which came from the WA technology, and we took these pictures on that table.
Oh.
Yeah, on air. So we have a lot of possibility to treat mathematically these pictures, to smooth, to gain a three-dimensional like picture, and so on and so on. For example, now here you are, and the pictures can be zoomed. Yeah. Okay, and I don't know how far do you know this method?
I'm in general, but not.
Yeah, okay. But it is so that very critical the stage of the tip during these measurements, because it must be very sharp and only a few atoms must be at the very top of the tip. So usually we use tungsten tips, but it is advisable to put some gold onto the end of the tungsten tip, because this gold can be shaped with easy, and it is much more resistant to chemical reactive gases like CO than the tungsten itself. Okay, so the trick is to pick some gold onto the end of the tip, and in order to achieve this we used on gold foil as well. At first we scan on the surface of the gold, and then later when the gold is picked up onto the end of the tip, then we change to the metal which we have an interest in. Just now it is platinum 110, and you know this surface can be reconstructed very easily by the adsorption of different gases, oxygen and heat treatment and argon bombardment and so on. So this is a very good test metal. Okay, unfortunately we do not have atomically resolved pictures on platinum. Only on gold it is something like an atomically resolved picture. I will show you this image. Yeah, one image. Now you may see that the peak-to-peak height in the Z direction is very small, only 6 angstroms, 9 angstroms, and it is a pity, but I must say that this is the best picture. You may see here some rows, and these rows belong to atomic rows, and perhaps it can be resolved that these are atoms, gold atoms. Otherwise, we were able to see very interesting, very exotic structures on the gold surface. And now we clean our sample, platinum sample, and try to absorb different gases. This is the story in short.
Okay.
So, I thought this would be the most interesting thing for you to see a movie.
Gábor, itt van?
Nem láttam még.
Akkor azért elmondod.
Persze, persze, köszönöm, majd becsukom utána.
Jó, itt van a Gábor.
Itt a Gábor.
Gábor is fél.
Hello, Gábor. First, may I introduce my colleague Gábor Krivényi.
How are you?
Well, in this lab we have two UHV apparatus. First is, may I call it a traditional one, UHV chamber equipped with different facilities for doing Auger and so-called surface science modern techniques. In the other UHV chamber we have a high-resolution electron energy loss spectrometer for studying the molecular structure of other species in infrared region of the spectrum. This is done by Gábor, who is investigating right now the adsorption of methyl chloride again. on which surface, Gábor?
Rhodium.
On rhodium surface. This is the first occasion that not palladium but rhodium is the surface. But probably in the next future he would do some experiments with palladium too. So you can see how can we combine all this technique, and and we will have enough time for doing that. Please go into the base lab where this gas chromatograph and another spectrometer, infrared spectrometer are right now. Thank you, Gábor.
Thank you. Well, you're relaxing now after the meeting is over.
But you see, somebody asked me whether did I have so many troubles with organizing this symposium, and my surprising answer was that there was no difficult job for me, because in organizing this symposium I have met with very helpful people, you know, and my colleagues too helped a lot. Hello. Please. Yeah. Good. You have met that's another infrared experiment. Gosh, will you be so kind to remove this cover? Yeah. Oh, that's it. Probably it would be exotic for you. I mean, this infrared spectrometer, because it's formerly called German Democratic Republic made speckled M80 from Carl Zeiss. This was their first computer-aided infrared machine, not so quick, etc., etc. Well, you have seen such kind of infrared cell already in the upper part of our experiment. Right now, Tamás is investigating the absorption of methyl halogenides on palladium again, and sometimes he is doing experiments on the absorption of methane carbon dioxide and methane carbon dioxide mixture. This later one is connected with another system investigated by us, by our co-workers, catalytically, I mean in classical catalytic method. Here a very old but very useful vacuum system is standing for doing experiments with the help of this old mass spectrometer. It's old but it's helpful.
If it works.
Yeah, it works. Tamás is is the best expert on this.
British made.
I guess it's nearly 20 years old, but it works. Probably you remember I have shown a picture during my lecture, MS analysis of the gas phase during the dissolvation of methyl chloride. It was done by Tamás in this system, so it's very useful data. Data can be obtained. Well,
This is which now we are studying the effect of illumination of the surface pieces. So that's the reason this is in a car. So when we remove it and using this American equipment to irradiate. And after we take the infrared spectrum, the trouble is that we have good results till now. It's not so.
probably the process is slower than you are.
Yes. We have to find another test reaction or something else to show any effect for illumination. Maybe in the next conference we will have published.
Okay, let's have a show for introduce that. So we have here two gas chromatograph. This is the Hewlett-Packard type. I'm sure you know that, but more exotically, this is a Czechoslovakian made old gas chromatograph. But it's work and we are doing experiments. Here, on this apparatus, we are studying the catalytic decomposition, of methyl chloride on silica supported palladium, and we have just turned to use another type of catalyst for having information which kind of catalyst would be the most effective in this reaction. And here my colleague is investigating the methane transformation reactions. That means that methane decomposition on different silica supported noble metals sometimes he is using a methane carbon dioxide mixture to investigate what happens on the surface or in this catalytic reaction using this gas mixture. It's a fantastic, very sophisticated machine, so everything can be made in there. And this is a derivatograph. This is a Hungarian produced one for measuring the mass loss, the heat evolution or heat absorption during the heating up of the sample. So this has been used particularly in our former topics when we have investigated the thermal decomposition of different inorganic compounds, chlorides, chlorates, and perchlorates, particularly. And we have been investigating also the effect of different additives, ions, oxides, etc. on this thermal decomposition of different halogenates. So that was our former, or more precisely, that was former topic of Professor Schornich. So that's all what I could show you in our okay. May I draw your attention to another thing? Probably you haven't recognized that. You know the slogan from Hamlet of Shakespeare, to be or not to be. This is more important, I think. To be or not to be, wrote Shakespeare.
Well, one should always include a little of the humor of the laboratory, right?
Prevent trouble. Fancy shortens life. That was the translation of James Henderson. He gave a lecture on Tuesday morning.
Oh yeah.
The Scottish
That's over. Shall we go to upstairs because
Okay.
Janos will